Greek yogurt benefits. 9. Insane things that happen. For many years, the pursuit of longevity has led us down paths involving intricate research, costly supplements, groundbreaking gene therapies, and futuristic pharmaceuticals. We've diligently explored complex avenues, often overlooking the profound impact that readily available, everyday elements can have on our biological well-being. It turns out that some of the most potent tools for extending not just our lifespan, but more importantly, our health span, have been right in front of us all along. These are the simple yet powerful biological shapers that work quietly and consistently, influencing our bodies on a cellular level every single day. Among these unassuming yet mighty allies is Greek yogurt. It's crucial to distinguish this from the sugar-laden imposters often marketed as healthy snacks. We're talking about authentic, traditionally strained Greek yogurt, a food that is exceptionally dense in protein, teeming with beneficial microbes, and possesses a unique metabolic profile. When incorporated into our diet consistently, this remarkable food transcends mere digestive support or muscle maintenance. It actively communicates with our cells, sending signals that profoundly influence critical biological processes. These signals are instrumental in modulating inflammation, enhancing insulin sensitivity, optimizing mitochondrial function, and even dictating the rate at which our bodies biologically age. What's particularly remarkable is that achieving many of these benefits doesn't necessitate drastic overhauls of our entire diet. A single, simple daily habit can be enough to tip the scales in favor of metabolic resilience, steering us away from the trajectory of metabolic disease. This journey will explore 9 scientifically fascinating transformations that begin to unfold when Greek yogurt becomes a regular part of your routine, especially for those focused on longevity, maintaining strength well past the age of 50, and ensuring long-term metabolic health. Let's begin by delving into the fundamental mechanisms that hold the most significance. One of the most consistently underappreciated drivers of aging isn't the superficial signs like wrinkles or gray hair, but rather the insidious and progressive loss of muscle tissue. This decline begins as early as our 30s and accelerates dramatically after the age of 50, with individuals potentially losing up to 1% of their muscle mass annually. This condition, known as sarcopenia, is far more than a cosmetic concern. It acts as a significant predictor of frailty, the onset of insulin resistance, a diminished capacity for independence, and even a shortened lifespan. In essence, muscle is not merely about physical strength. It functions as a vital metabolic organ that plays a crucial role in how effectively and healthily we age. What elevates Greek yogurt to a position of particular interest in this context is not simply its protein content, but the unique way in which its proteins are processed and utilized by the body. The process of straining inherent to Greek yogurt production effectively removes a significant portion of lactose and liquid whey. What remains is a highly concentrated matrix of complete proteins, notably rich in leucine. Leucine is an amino acid that acts as a critical molecular trigger, essentially an on switch for muscle protein synthesis. It directly activates a cellular pathway known as mTORC1, mechanistic target of rapamycin complex 1. While mTORC1 is often discussed in longevity science as something to be suppressed, its role is nuanced. Chronically elevated mTORC1, often driven by constant overeating and persistently high insulin levels, can indeed accelerate aging. However, context is paramount. Short, targeted activation of mTORC1, such as in response to resistance training or the consumption of high-quality protein, is absolutely essential for preserving muscle mass and maintaining functional capacity as we age. Greek yogurt provides precisely this kind of controlled physiological signal. Unlike refined carbohydrates or ultra-processed protein products, Greek yogurt delivers leucine in conjunction with essential cofactors like calcium, beneficial probiotics, and bioactive peptides that actively modulate the body's insulin response. This means you receive the vital muscle-building signals without the excessive insulin spikes that are often contributors to broader metabolic dysfunction. For aging adults, this delicate balance is absolutely critical. While preserving muscle is a priority, it must not come at the expense of overall metabolic health. Another significant advantage of Greek yogurt lies in its digestibility. As we age, stomach acid production tends to decline, which can diminish our ability to efficiently digest dense protein sources like red meat. The proteins in Greek yogurt, primarily casein with some residual whey, undergo a partial fermentation and predigestion process. This predigestion allows amino acids to enter the bloodstream more efficiently, thereby reducing digestive stress while still providing a sustained release of essential building blocks to muscle tissue. This slow, sustained release of amino acids is highly beneficial. Casein protein, in particular, has been shown to provide a prolonged anabolic signal, effectively reducing overnight muscle breakdown. When Greek yogurt is consumed in the evening, it can help to blunt the natural increase in muscle protein degradation that occurs during sleep, a phenomenon that is particularly pronounced in older adults. Practically speaking, this translates to waking up with less muscle loss and a more stable metabolic state. The importance of muscle preservation extends beyond simply preventing weakness. Skeletal muscle is one of the body's largest repositories for glucose. The more muscle mass we maintain, the more efficiently we can clear glucose from our bloodstream. This directly enhances insulin sensitivity and significantly reduces the workload on the pancreas. Therefore, by supporting muscle mass, Greek yogurt indirectly acts as a protective agent against type 2 diabetes, a disease known to dramatically accelerate biological aging. Furthermore, there is a hormonal component to consider. Adequate protein intake is crucial for the production of insulin-like growth factor 1, IGF-1. In moderate tissue-specific amounts, IGF-1 is necessary for muscle maintenance and repair. Greek yogurt appears to support this physiological IGF-1 signaling without pushing it into the chronically elevated ranges that have been associated with increased cancer risk. Again, this highlights the importance of balance rather than extremes. For older adults, a phenomenon known as anabolic resistance presents a significant challenge. Muscle cells become less responsive to protein intake, requiring higher quality protein to elicit the same anabolic response seen in younger individuals. Greek yogurt effectively meets this requirement. Its concentrated leucine content helps to overcome anabolic resistance, making it an exceptionally effective protein source for individuals over the age of 50. Interestingly, this beneficial effect is further amplified when Greek yogurt is consumed following light resistance exercise. Even simple activities such as walking with an incline, performing bodyweight movements, or using resistance bands can initiate a synergistic effect. The combination of mechanical tension on the muscles and the leucine signaling from the yogurt creates a powerful response that helps preserve muscle fibers and maintain neuromuscular coordination. Over time, this translates into improved balance, a reduced risk of falls, and a greater degree of independence. What is often overlooked is the intimate connection between muscle health and mitochondrial function. Healthy muscle tissue is characterized by a high density of mitochondria, the cellular powerhouses responsible for energy production. With age, mitochondrial number and efficiency tend to decline. By supporting the maintenance of muscle mass, we are indirectly preserving the number and functionality of mitochondria, which in turn supports endurance, metabolic flexibility, and the body's overall resilience under stress. Greek yogurt, by facilitating consistent protein intake without imposing a metabolic overload, contributes indirectly to this vital mitochondrial preservation. Additionally, emerging evidence suggests that fermented dairy proteins, like those found in Greek yogurt, produce bioactive peptides during digestion. These peptides have demonstrated the ability to reduce oxidative stress within muscle tissue. Oxidative damage is considered one of the primary hallmarks of aging, and muscle tissue is particularly vulnerable due to its high energy demands. Mitigating this oxidative burden is crucial for slowing functional decline. Perhaps most importantly, Greek yogurt makes muscle preservation a sustainable endeavor. True longevity is not achieved through short-term intensive interventions, but through the establishment of habits that can be maintained consistently over decades. Greek yogurt is accessible, affordable, and culturally adaptable. It doesn't demand extreme dietary shifts or the reliance on immense willpower for restriction. Instead, it simply provides the body with signals that it understands. Signals that promote strength, maintain function, and foster resilience. From a longevity perspective, this approach is crucial. The ultimate goal is not to maximize muscle mass at any cost, but rather to maintain sufficient muscle to support metabolic health, mobility, and independence well into old age. When consumed consistently and thoughtfully, Greek yogurt becomes a silent, supportive ally in this process, activating muscle preservation pathways without inadvertently accelerating the aging clock. It is this fundamental distinction that separates a true longevity food from a fleeting fitness trend. A profound shift in aging research over the past decade has been the growing recognition that we do not age in isolation. Our bodies are home to trillions of microorganisms, collectively forming what is often referred to as the gut microbiome. These microorganisms function almost as an additional organ, constantly communicating with our immune system, our metabolism, and even our brain. This intricate internal ecosystem plays a decisive role in determining the pace and quality of our aging process. What makes Greek yogurt uniquely relevant to longevity is its remarkable ability to gently yet consistently reshape this microbial landscape. High-quality Greek yogurt is a source of live probiotic cultures, most commonly potentially pathogenic species. Calcium, in particular, has been shown to bind to harmful bile acids, thereby reducing their inflammatory impact on the gut lining. A healthier gut barrier has far-reaching systemic consequences. When the intestinal lining is compromised, fragments of bacteria, such as lipopolysaccharides, LPS, can leak into the bloodstream. This phenomenon, known as metabolic endotoxemia, triggers chronic, low-grade inflammation. This type of inflammation is a defining characteristic of aging and is a major contributor to cardiovascular disease, neurodegeneration, and insulin resistance. By reinforcing the gut barrier, Greek yogurt effectively helps to reduce this inflammatory burden at its very source. The gut is also intricately connected to the immune system, with approximately 70% of immune cells residing in or around the gut-associated lymphoid tissue. Beneficial microbes nurtured by fermented foods promote immune tolerance rather than an overzealous immune response. This helps to reduce the risk of autoimmune disorders and dampens age-related immune decline, a process known as immunosenescence. Interestingly, the microbiome also communicates with the brain through what is termed the gut-brain axis. Microbial metabolites can influence the production of neurotransmitters like serotonin and gamma-aminobutyric acid, GABA. These molecules have a significant impact on mood, stress resilience, and sleep, all factors that indirectly influence longevity by shaping behavior, hormonal balance, and inflammation. Regular Greek yogurt consumption has been associated with improved mood stability and reduced stress responses, which may offer a partial explanation for why dietary patterns rich in fermented foods often correlate with better cognitive aging. From a metabolic perspective, the microbiome acts as a crucial gatekeeper for energy balance. Certain bacterial profiles are associated with improved insulin sensitivity and enhanced fat oxidation, while others tend to promote fat storage and inflammation. Greek yogurt appears to shift this balance towards microbes that enhance metabolic flexibility, the body's ability to efficiently switch between using glucose and fat as fuel sources. Metabolic flexibility is a hallmark characteristic of populations with exceptional longevity. Furthermore, there is emerging evidence suggesting that the microbiome influences epigenetic regulation, the chemical modifications that control gene expression without altering the underlying DNA sequence. SCFAs, particularly butyrate, function as histone deacetylase inhibitors. In simpler terms, they help to keep genes involved in stress resistance, DNA repair, and metabolic regulation switched on. This is a critical intersection where diet directly impacts the epigenetic mechanisms of aging. The fermentation process inherent to Greek yogurt further enhances its longevity-promoting profile by breaking down lactose and generating bioactive peptides. These peptides have been shown to reduce oxidative stress and improve endothelial function, both of which are crucial for cardiovascular health and are influenced by microbial activity. The synergistic interaction between these peptides and gut bacteria creates a feedback loop that reinforces both metabolic and vascular health. What is particularly compelling about these effects is that they do not necessitate perfection in consumption. You do not need to consume enormous quantities or actively seek out exotic probiotic strains. Consistency is far more important than intensity. A modest daily intake of Greek yogurt provides a steady microbial signal, one that gently nudges the gut ecosystem towards stability rather than volatility. This stability becomes increasingly important as we age. Older adults are more susceptible to disruptions caused by antibiotics, illness, and dietary changes. A resilient microbiome is better equipped to recover quickly from these insults, thereby reducing the risk of cascading health declines. Greek yogurt functions almost like a microbial anchor, helping to maintain equilibrium during periods of physiological stress. From a longevity perspective, this is vital, as aging is not typically caused by a single pathway failing, but rather by the gradual breakdown of multiple interconnected systems. The gut microbiome sits at the nexus of many of these interactions. By supporting microbial diversity, gut barrier integrity, immune regulation, and metabolic signaling, Greek yogurt exerts a profound systems-level influence on the aging process. Perhaps the most critical takeaway is that the microbiome responds to our daily actions, not to infrequent interventions. Longevity is constructed through repeated, consistent signals, not through dramatic, one-off interventions. Greek yogurt provides a daily microbial cue that reinforces resilience, reduces inflammation, and supports the fundamental biological processes that help us remain functionally younger for longer. In the context of aging science, this elevates it to a role far beyond that of a simple food. It becomes a sophisticated form of nutritional communication, directly engaging with the microbes that play a pivotal role in how we age. One of the most potent accelerators of aging in modern society is not solely excess weight, but rather chronically elevated insulin levels. Long before blood sugar reaches diabetic thresholds, persistently high insulin silently drives inflammation, promotes fat storage, contributes to vascular damage, and accelerates cellular aging. In the field of longevity research, insulin resistance is increasingly understood not as an isolated disease, but as a systemic breakdown in metabolic signaling. What makes Greek yogurt particularly noteworthy is its ability to improve insulin sensitivity without demanding extreme dietary restriction or imposing metabolic stress. It achieves this not by forcing the body into a state of deprivation, but by restoring the very signals to which human metabolism evolved to respond. Insulin is fundamentally a storage hormone. When its levels remain elevated for prolonged periods, the body's cells become less responsive to its signals, compelling the pancreas to release even more insulin. This creates a detrimental feedback loop that accelerates aging by activating inflammatory pathways, suppressing autophagy, the cellular cleanup process, and increasing oxidative stress. The primary objective of a longevity-focused diet is not to eliminate insulin entirely, but rather to ensure that the body remains responsive and efficient in its use of this crucial hormone. Greek yogurt contributes to this goal through a synergistic combination of macronutrient balance, high-quality protein, and influential microbial signaling. In contrast to refined carbohydrates, which cause rapid spikes in blood glucose and consequently insulin, Greek yogurt possesses a low glycemic load. Its carbohydrates are largely encapsulated within a matrix of protein and fat, which inherently slows down digestion and moderates the rate at which glucose is absorbed into the bloodstream. The protein component itself plays a critical role. High-quality protein stimulates the release of incretin hormones, such as GLP-1, which are known to to enhance insulin sensitivity and promote a feeling of satiety. These hormones enable the body to handle glucose more efficiently with a reduced demand for insulin. This is a significant reason why meals containing adequate protein consistently result in better glycemic control compared to meals that are primarily carbohydrate-heavy. The fat content of Greek yogurt, particularly when opting for full-fat versions, further contributes to blood sugar stabilization. Dietary fat slows gastric emptying, which consequently reduces the speed at which glucose enters the bloodstream. This results in a smoother, more controlled insulin response, rather than the sharp spikes and subsequent crashes often experienced with high carbohydrate meals. From a cellular perspective, this moderation reduces metabolic stress and helps preserve the functionality of insulin receptors. Another important factor is calcium. Higher dietary calcium intake has been consistently associated with improved insulin sensitivity and a reduction in fat accumulation within adipose tissue. Calcium plays a role in modulating intracellular signaling pathways that influence how fat cells respond to insulin, making them less prone to excessive energy storage. Greek yogurt provides calcium in a highly bioavailable form, meaning the body can readily absorb and utilize it. However, perhaps the most underappreciated mechanism through which Greek yogurt influences insulin sensitivity involves the gut microbiome. As previously discussed, microbial metabolites have a systemic impact on insulin signaling throughout the body. SCFAs, for instance, are known to improve insulin sensitivity in muscle and liver tissues, while simultaneously reducing inflammation in adipose tissue. By fostering a healthier microbiome, Greek yogurt indirectly enhances systemic glucose control. This microbiome-mediated effect helps explain why fermented dairy products often demonstrate superior metabolic benefits in studies compared to their non-fermented counterparts. The fermentation process alters how nutrients interact with the body, generating compounds that directly influence insulin pathways. Observational studies consistently link regular yogurt consumption to a reduced risk of type 2 diabetes, even when overall calorie intake remains unchanged. This is a critical insight. Many dietary strategies aimed at improving insulin sensitivity rely on calorie restriction or carbohydrate reduction. While these methods can be effective, they are often challenging to sustain long-term. Greek yogurt, on the other hand, improves insulin sensitivity by enhancing how the body processes the nutrients it is already consuming, without necessarily requiring a reduction in overall food intake. From a longevity perspective, sustainability is of paramount importance, often outweighing the intensity of an intervention. The body responds most favorably to metabolic stability rather than cycles of restriction and subsequent indulgence. Greek yogurt provides this stabilizing influence, blunting post-meal glucose excursions and thereby reducing the overall insulin burden throughout the day. There is also an interaction with muscle tissue that is frequently overlooked. Muscle serves as the primary site for glucose uptake. By supporting muscle mass, Greek yogurt increases the body's capacity to absorb glucose without necessitating elevated insulin levels. This establishes a beneficial virtuous cycle. Improved muscle health leads to enhanced insulin sensitivity, which in turn protects muscle from further metabolic damage. In aging adults, insulin resistance can develop even in the absence of obesity, a phenomenon sometimes referred to as normal weight metabolic dysfunction. This condition is often driven by muscle loss, an increase in visceral fat, and chronic inflammation. Greek yogurt effectively addresses all three of these factors simultaneously, making it a particularly valuable food for older populations. Another important consideration is the timing of consumption. Consuming protein-rich foods like Greek yogurt earlier in the day has been shown to improve glycemic control across subsequent meals, a phenomenon known as the second meal effect. This implies that a single serving can positively influence insulin response for several hours hours afterward, smoothing out metabolic fluctuations throughout the day. This effect may be mediated by reduced free fatty acid release from adipose tissue and improved hepatic insulin sensitivity, meaning the liver becomes more efficient at regulating glucose output, thereby reducing both fasting and post-meal blood sugar levels. This reduction in constant metabolic noise helps to slow cellular aging. Chronic insulin elevation also has the effect of suppressing autophagy, the cellular recycling process responsible for removing damaged proteins and organelles. While Greek yogurt, due to its protein content, does transiently activate mTORC1, the overall improvement in insulin sensitivity facilitates longer periods of low insulin between meals. This creates necessary windows for autophagy to occur naturally without requiring extreme fasting protocols. This balance is crucial. Longevity is not about permanently shutting down growth pathways, but about restoring their natural, cyclical rhythms. Greek yogurt supports this rhythm by enabling efficient nutrient processing followed by periods of metabolic rest. Furthermore, there is evidence suggesting that fermented dairy proteins can reduce postprandial inflammation, a type of inflammation that occurs after eating and is closely linked to insulin resistance. In individuals with insulin resistance, inflammatory markers often rise after a meal. Greek yogurt appears to blunt this response, thereby reducing oxidative stress and preserving vascular function. Over time, these seemingly small improvements compound. A lower daily insulin exposure translates into less glycation of proteins, reduced endothelial damage, and a slower progression of age-related diseases. These are not dramatic, immediate effects, but longevity is ultimately built upon the accumulation of subtle, consistent advantages. What makes Greek yogurt particularly compelling is its alignment with how human metabolism evolved. Our ancestors consumed fermented foods regularly, not as specialized supplements, but as dietary staples. These foods provided metabolic signals that are largely absent in modern, ultra-processed diets. Reintroducing them helps to restore a form of metabolic communication that has been lost. In the context of aging science, the ability of Greek yogurt to improve insulin sensitivity without imposing restrictive dietary measures represents a significant paradigm shift. It moves us away from interventions reliant on willpower and towards solutions that leverage our environment. Greek yogurt becomes not merely a diet food, but a metabolic stabilizer, quietly improving insulin signaling day after day. And in the pursuit of longevity, this quiet, consistent efficacy often proves more, reducing their tendency to become overactivated. Magnesium and potassium, often present in dairy products, can help counteract oxidative stress and stabilize cell membranes. These subtle molecular influences, when applied consistently over years, accumulate to produce meaningful reductions in the body's baseline inflammatory tone. Another important mechanism involves the interaction between Greek yogurt and senescent cells. Senescent cells are damaged cells that have ceased dividing but continue to secrete a potent mix of inflammatory cytokines, a phenomenon known as the senescence-associated secretory phenotype, SASP. While no single food can eliminate senescent cells entirely, improving overall metabolic and microbial health through the consistent consumption of fermented foods appears to reduce the systemic impact of the SASP. Essentially, Greek yogurt can help blunt the inflammatory output from these aging cells, indirectly slowing tissue deterioration. The timing and context of consumption also play a role, further influencing the body's response and contributing to a more resilient and youthful biological state.